Serverless through cloud-native architecture. Abstract: many enterprises prefer technologies that meet their business needs and requirements. Change of market dynamics continuously demands proliferation of latest technologies. Microservices, serverless computing, artificial intelligence, machine learning, and IoT are few latest technologies. Ongoing technology changes insist software companies to bring quick new products with latest features as expected by client. Global modern software legends stress the need of adoption of cutting-edge technologies, frameworks, tools, and infrastructure, so that applications can take the advantages like faster delivery, lightweight, scalable, and lower developing and maintenance cost. Digital transformation has become very essential for serverless computing. Digital transformation has accelerated business models. Some of them are favorites of serverless technologies, microservices, and native cloud applications. These initiated a new transformation in the technological areas. Stateless functions impact on the maintainability of the software. Enterprises will now concentrate on their products and services to sustain global software market. Hence, an implementer can run an application on a third-party server, and this will in turn decrease deployment time. Serverless too is a hot topic, and, in software world, serverless computing has evolved as new important technology for deploying cloud-based applications. Serverless is latest execution model of cloud. Provider of cloud will allocate resources at runtime. Calculation of cost is based on owned resources by an application. Serverless has advantage in especially event-driven applications. By adopting serverless computing, organizations avoid approaches like going for new hardware components, installing, configuring, and troubleshooting, which is cost-effective and time-consuming. Fast and fair growth in computing technologies will push corporate to adopt serverless environment, hence augmenting the market. Serverless programming is a new paradigm in modern software world. Serverless leaves technological knowledge gaps, to be answered and still to be explored by research community. Aim of this paper is to put light on modern architectural design concepts of serverless technologies and also technical trends about the future of cloud applications. Most of the cloud vendors provide almost all kind of serverless components. This paper acts as a guide to technical audience on the usage of serverless and cloud component. Keywords: cloud-native applications, microservices. 16, Amazon Web Services, AWS, for cloud computing, serverless computing / architecture, AWS Lambda 5, Azure Function 4, Backend as a Service, BaaS, and Function as a Service, FaaS. Introduction. Earlier architectures like client/server generally have a server process. Just like as in the case of web server or a message queue listener, in this process server listens to a socket. Serverless computing is a programming model in which no code piece is executed in the cloud. It is responsibility of cloud providers to provide resource provisioning, monitoring, maintenance, scalability, and fault tolerance. Serverless platforms allow writing scalable microservices easier and cost-effective. Serverless architecture is an emerging revolutionary step in leveraging cloud-based technologies. Serverless computing is a lightweight computing solution and allows users to create smaller units of scale, stateless functions. Serverless computing operates in an expansible manner with needless to manage the server or executable environment. Serverless is new cloud-based model of execution, to modify the design and development of latest scalable web applications. Serverless architecture is a set of functions. Life cycle of serverless services begins at deployment and ends with the approaches to scalability. Serverless is ancestor of earlier cloud technologies, infrastructure as a service, in cloud, cloud provider provides servers and storage. Serverless technologies, there is no need to care about computer resources like servers and storages. The name serverless will coincide with other similar names such as platform as a service, PaaS, and software as a service, SaaS. Serverless architecture is emerging cloud application architectural pattern modernizing the design of cloud-native applications. Both application logic and the database server reside in the cloud in traditional tiered cloud application. Serverless application contains the business logic in the client. Servers and computing resource management are dealt by cloud providers D. In serverless there are no virtual machines or physical servers, cloud vendors deploy automatically in the cloud. Serverless is a combination of function as a service, FaaS, and backend as a service, BaaS. Serverless equals function as a service, FaaS, plus backend as a service, BaaS. Serverless is the latest generation cloud computing technology. Serverless became popular as function as a service, FaaS. In serverless technologies, applications are launched by a third-party service, which helps an implementer in dealing with hardware and software management. Serverless technologies force enterprises to concentrate on their core products and services, instead a lot of expenditure on their IT infrastructure. Thus, organization can run on a third-party server and reduce deployment time. Cloud Native Computing Foundation, CNCF, hosts important components of worldwide technology infrastructure. The components of Cloud Native Computing Foundation, CNCF, are as shown in Figure 1. CNCF makes the global top developers, end users, and vendors under one umbrella and runs the biggest open-source developer conferences. The definition of serverless computing as given by Cloud Native Computing Foundation, CNCF, 29 is building and running applications that do not require server management. It describes a finer-grained deployment model where applications, bundled as one or more functions, are uploaded to a platform and then executed, scaled, and built in response to the exact demand needed at the moment. There are different layers in cloud-native architecture. These are pluggable layers based on the best tool that suits requirement. The following Figure 1, Cloud Native Computing Foundation, CNCF, provides a simplified view of such architecture. According to Mike Roberts, serverless architectures refer to applications that significantly depend on third-party services. The word serverless one is similar to the word not only SQL, no SQL, creating confusion, and doesn't mean there are no servers. In serverless technology, third-party services are placed in the front so that removes the need for the traditional applications depending on server. Serverless computing is event-driven model. Event-driven cloud computing model refers to computing resources that are scalable cloud services. Earlier, the organizations used to pay a fixed amount for their website and application irrespective of all their usage. This causes additional charges for idle time and downtime. But with latest technology in place, it is required to pay only for the used services or instances. No charges for downtime and idle time. This results in reduce in their operational cost and complexity of application. Background knowledge. Serverless architecture. Present software error refers to cloud programming models, and also as a proof of maturity for the adoption of cloud technologies across the globe. Earlier function as a service, FaaS, 3 is nothing but today's cloud computing technology. Serverless applications seem to be more scalable and are normally cost-effective. Serverless as a concept is not new. Serverless has limitless storage with scaling level at infinity and with zero maintenance of servers. The basic concept of was introduced by Cncf 1. In the year 2006, for first time Cncf announced pay-as-you-go first serverless platform. But Amazon has commercialized this concept by launching Cloud Storage Service, AWS S3, a serverless service in 2006. New paradigm has been defined with the compute services leading towards serverless. Software giant Amazon in 2014 announced a serverless technology AWS Lambda. Other technology giants such as Microsoft, Google, IBM, etc. explored this newly evolved concept cloud technology. Microsoft launched serverless cloud infrastructure after AWS Google to get the second position. Serverless evolution has process with many stages. Below Figure 226 describes various stages in the evolution of serverless computing. In the first stage, virtualization technology virtualizes many big servers into one individual virtual machine, VM, resource. In next stage, virtualization clusters are placed in platforms, cloud computing. In the next stage, depending on the operating space minimization principle, each virtual machine, VM, is divided into Docker containers. In last stage, applications are built on top of Docker containers, only a serverless architecture for the core. No runtime environment management is required. Serverless architecture is an event-driven model. The developer and the service consumer provides infrastructure such as physical and virtual devices, operating systems, virtual machines, and containers. Apps run in stateless containers. Apps are handled based on occurrence of an event. Serverless functions encapsulate application logic or business logic. Application logic or business logic runs on containers. Cloud provider manages scaling of equipment needed, capacity planning and management, virtual machines, server capacity, and operating systems. Third-party services, known as backend as a service, BaaS, or on the custom code are depended by serverless architectures. Custom code runs in stateless containers, known as function as a service, FaaS. Third-party services are short-lived, invoked by event, and fully managed by the cloud provider. Developer writes concise and stateless functions that are triggered through an event. An evolution of serverless computing is rise of cloud computing service models. Cloud services raises from infrastructure as a service, IaaS, to platform as a service, PaaS, down to function as a service, FaaS. Infrastructure as a service, IaaS, grills out underlying equipment to provide virtual machines. PaaS abstracts operating system and middleware to provide the development platform. Function as a service, FaaS, deploys and runs function irrespective of deployment platform. Leading cloud providers started using serverless services since last 2 or 3 years. Amazon called its service as AWS Lambda, started in 2014, Microsoft called serverless services as Azure Functions, started in 2015, and Google called it serverless as Google Functions, started in 2016 alpha release. Components of serverless computing 2. There are key core technological. Serverless API Gateway 7. The Serverless API Gateway is layer of communication between the front end and the FaaS, function as a service. API Gateway link REST API and business logic functions. It is not needed to deploy and manage load balancers in this model. Functions or function as a service, FaaS. In this specific business logic is executed. The level of abstraction is in terms of running the business logic. Backend as a service, BaaS. Backend as a service, BaaS, refers to cloud-based distributed NoSQL database and eliminate database admin burdens. Serverless application architecture. The following figure 4 shows the serverless application architecture 19. Figure 4 above shows a user accessing a serverless application through a cell phone. HTTP request by user is passed by a domain name server, DNS. Outcome of the request is given through Content Delivery Network, CDN, which talks to an object storage medium. Content Delivery Network, CDN3, is most preliminary form of a service that provides instantaneous distribution. The runtime content is given to a web server by routing its requests through API Gateway. The gateway redirects application requests to many functions. One function is used for one service, another function reads and writes to a backend database while the third function saves state. Function as a service, FaaS, one allows to upload and execute code without bothering about scaling, servers, or containers. Evolution of the container methodology can be attributed to serverless. It has limitations that are less prominent than in platform as a service, PaaS. The biggest advantage of function as a service, FaaS, is scaling. Scaling FaaS can be done at a lower granularity than platform as a service, PaaS, or container as a service, CaaS, and does not require any configuration. Microservices architecture 16 and cloud computing moves hand in hand and is the best fit from both the sides. Serverless cloud computing sounds similar as microservices. An extension of microservices is nothing but serverless computing. 15. There are specific core components in serverless architecture. Microservices bundles functionalities with similarity into single service. Bigger functionalities are divided into many smaller components. Executors create custom code and execute it as independent and isolated functions that run in stateless services. The below diagram figure 3 shows comparison of serverless with traditional architecture. 12. Traditional approaches to serverless. The 3 approaches used are virtual machine approach, container approach and serverless approach. VM approach. IaaS is implemented using virtual machines, VMS. Abstracting the physical machine from guest operating systems is leveraged by virtualization. So-called hypervisor or virtual machine monitor, VMM, can be utilized for spawning and expunging virtual machines, VMS. Virtual machines, storage, network, and other compute resources are provided to the customers as a service. Apart from underlying cloud hardware infrastructure that enables IaaS, customers manage operating systems, storage, network, and applications. VM-based approach is standard for multi-tenant scenario. VMS are too heavyweight for serverless function execution. Container approach. Containers can be run as isolated processes. Containers are distinguished from each other by using the system having security features. Some of the distinct containers are Linux containers, LXC, Dockers, and Windows containers. These containerize the applications into processes with a dedicated file system. A complete execution environment by containers, while staking the host binaries and libraries, wherever suitable. Most of the giant cloud providers in global market, Amazon, Google, Microsoft, IBM, and others use container-based approach technology. Serverless is another way of decoupling from underlying infrastructure. In microservice architecture, monolithic applications are broken into small services that can be developed, deployed, and scaled individually. Serverless architectures splits into more fine-grained and loosely coupled. For event queuing, messaging, databases, and serverless complement more traditional microservice and virtual machine, VM, based approaches and regular third-party cloud services. Serverless approach. Enterprise focuses mostly on serverless programming. Function as a service, FaaS, is also known as serverless computing. It means there is no server to manage. This takes advantage of the growth in cores and processors within the cloud and enterprise systems. Serverless computing services like Amazon's AWS Lambda or Apache OpenWhisk. Serverless computing is based on small functions that to run on demand for short periods of time. A serverless system may easily track the amount of time a function runs while limiting the resources it can use. Another reason is that they support event-driven workloads that often arise with the Internet of Things, IoT. A serverless function can be invoked on getting message from IoT. It is easy to scale the response based on demand with the underlying system handling this management instead of building it into the application. Security in serverless environments. The operating system and management environment provide mechanisms to allow the serverless functions to only access their provided resources. Serverless functions can be implemented through languages like JavaScript or Python. Issue with serverless solutions is vendor or platform lock-in, since the application is dependent on the underlying framework. But, in this IoT age, part of a solution may reside in the cloud on a public service like AWS Lambda. VM-based versus containers versus serverless. 28. More flexible and scalable apps compared to serverless computing and containers built earlier. Servers and virtual machines. Serverless and containers are quite different technologies. In both serverless computing and containers, infrastructure expenses are reduced significantly. There are key differences between serverless and containers. Fast releases and iterations will be given by serverless architecture, and containers give more control over the environment. Hybrid architectures can also be used in this regard. Comparison of VM, containers, and serverless is as given below. Figure 5 Comparison of VM, containers, and serverless. Physical machines. Serverless architecture will be running on servers that are provided by the vendors. A specific app or function doesn't have a particular machine assigned. Each container exists on one machine, uses its operating capacity, and can be moved to another even if needed also. Supported host environments. Modern Linux server and also some versions of Windows containers execute on any platform. In contrast, serverless can run only on particular host platforms based in the public cloud, like AWS Lambda or Azure Functions. Supported languages. As long as the host server supports the language, any application can be developed by using the container. Serverless frameworks support a limited number of languages. The details of supported serverless language vary from serverless platform to platform. Self-servicing ability. For serverless functions, a public cloud required. There are on-premises serverless frameworks, with containers, that allow set up own on-premises host environment, or use a public cloud service like ECS. Scalability. Serverless architecture, backend can be scaled based on demand. But for scalability with containers needs to decide on their number before. Cost efficiency. Even if app is not used needs to pay for space since containers are constantly running, whereas in serverless computing, the code executes only upon calling, and is paid for the executed period only. Maintenance. Serverless, there's no backend to manage. But maintaining and updating of container environment is needed while hosting in container. Availability. Containers can run for as long as needed, whereas serverless functions are available for only a short period. Down. Deployment. Configure system settings, libraries, etc. are required to set up containers, and takes longer. In a serverless architecture, the moment the code is uploaded. Statefulness. Stateless supported by most serverless platforms. Some limited support for stateful services is supported by serverless providers. Example: durable functions on Azure containers present their own persistent storage challenges, but creating stateful containerized apps is certainly possible. Testing. It's hard to replicate a backend environment in the local environment, so testing is challenging in serverless apps. Containers, however, tested easily. See differences between serverless and containers 11,12. Workloads are deployed on-premises on a generic cloud infrastructure. Workloads are deployed in public infrastructure with a limited tool set to manage and secure. May not constantly consume resources as it is designed to run longer period of time. Workloads may consume large amount of data in short amount of time. Types of serverless systems. Table 2. Comparison of containers and serverless functions. First, serverless computing is as given by Cncf is function as a service, FaaS. It has all types of cloud services. The 8 general types of serverless systems, based on their primary purpose, is as given below. Computing. Queue buffer. Stream passing. Event bus. Database. Blob storage. API endpoints. Authentication management. Key architectural considerations. Serverless computing has a lot of advantages when compared to traditional cloud-based or server-centric applications. Serverless architectures provide high scalability, high flexibility, and less release time and reduced cost. Serverless architecture is a new execution model. By adopting this architectures, customers produce next-generation products from concept to production, without waiting for any infrastructure. Its benefits are reflecting efficiencies, lowering costs, and less marketing time. Separation of developers and operational aspects. The most important pro with serverless computing is clear separation between the developer and the operational aspects of deploying code into production. Cost. Key advantage of a serverless platform is the ability to scale to 0 instances. Usage of serverless technology is metered. Services memory or CPU, pricing model, off-peak discounts are metered. Customers/clients are charged for only he used time and resources. Stateless functions, any kind of resource within a serverless function, like storing session state in a persistent database, unseen after the function refrain to exist. Ephemeral functions, serverless functions are saved for a certain period of time. Serverless functions are deployed in a container. Containers are invoked upon a triggering an event and sustain active for a certain period, after which it shuts down automatically, and thereafter all resources within the container refrain to exist. Hence applications having high processing requirements may not suit for serverless. Polyglot programming, serverless functions/services can be developed by using lot of programming languages including JavaScript, Java, Python, Go, C#, and Swift. Polyglot programming is supported by many platforms. For example, Node.js, Python, and Java are supported by AWS Lambda, C#, JavaScript and, preview of F#, Python, Batch, PHP, and PowerShell, are supported by Azure Functions. Only JavaScript is supported by Google Functions. Selecting a platform is the choice of language for development. Security and accounting, multi-tenant supported by serverless platforms. Serverless functions isolate the execution of functions between users. Hence clients, no amount that they need to pay. Monitoring and debugging, serverless services own their own logging and monitoring built-in mechanisms. By using print statements that are recorded in the logs, all platforms support basic debugging. Programming model, a serverless platform execute a single function by taking JSON object, dictionary, as input and returns a JSON object, dictionary as output. Composability, serverless technologies, allow one invocation of one serverless function from another serverless function. Deployment, serverless platforms make deployment very simple. By giving a file with the function source code. Multiple files or Docker image with binary code are included in the package. Cold start will happen whenever a function is inactive and is invoked for the first time. Time taken by the container running the function for loading the runtime along with the libraries and also dependencies is called cold start. Cold starts increases the execution time significantly. If cold start is not handled properly, serverless functions affects application performance. Recommended guiding principles or best practices. Code on demand, 21. A serverless compute services such as Amazon Lambda, Microsoft Azure Functions, AUTH0 Web Task, or Google Cloud Functions must be used to execute code. Do not execute or manage any own servers, own VMS, or own containers. Custom code should be entirely run out of function as a service to gain the most benefit. Single-purpose stateless functions 21. Serverless functions are stateless and persist for a bounded duration only. Using single responsibility principle, SRP, of Solid 6 principle of design, only write functions that have one and only one responsibility. This helps in limiting the execution time of a function, which has a direct impact on cost. In addition, single responsibility codes are agile, easier to test, deploy, debug, and release. These could be microservice with appropriate level of granularity based on requirements and context. Finally, even though statelessness may be perceived as a limitation, it provides infinite scalability to a platform to handle an increasing number of requests, which otherwise would not have been possible. Create thicker and powerful front ends 21. To reduce cost, use rich client front end by minimizing function calls and execution times. Completely decoupling back-end logic from the front end allows more services to be accessed from front end. This results in better application performance and richer user experience. Moving more code to the front end helps in limiting the number of serverless functions. Design push-based, event-driven patterns 21. Designing event-driven architecture patterns to carry out complex computations and tasks is always good. In this, a chain of events propagate without any user input imparts scalability. Use a serverless to avoid polling or manual intervention. Security mechanism across the technology stack. At the API gateway layer and also at the function as a service, FaaS, layer, suitable security mechanisms must be implemented. Features like access controls, authentication, identify and access management, IAM, encryption, and establishing trust relationship etc. are included in security mechanism. Identify performance bottlenecks. Live measurement of performance bottlenecks in terms of identifying which functions are slowing down a particular service is critical to ensure optimal customer experience. Leverage third-party services. Live enterprise tools for various services may not be compatible with serverless. As serverless is an emerging concept, choosing the right third-party tools is key for enterprises to make certain the benefits of serverless are utilized to the fullest. Serverless Metrics. Metrics provided by FaaS will assist to observe performance of a serverless function. Table2 given below gives metrics of serverless. Best servers in serverless technologies 12. AWS Lambda 24. As serverless cloud platform is the most preferred and functionally sound, organizations execute their applications having no server. Companies are cost effectiveness by paying for used code of execution. Lambda works with any type of backend service or application for obtaining zero administration. Lambda authorize running the code virtually. The Lambda can also be scaled resources as per the specific requirements of the organizations. Lambda can scale and execute code at greater availability. Building advanced data processing, real-time file processing, real-time stream processing, data validation, filter, and sorting, and backends, IoT backends, mobile backends, web applications, AWS Lambda is very useful. Upon adopting AWS Lambda, implementers can stress on application logic rather than number of instances and kind of services. Entire architectural information can be placed on the cloud and easily respond to external events. Azure Functions 24. Azure Functions are same as AWS Lambda. Azure Functions assist implementers to execute an event based on for upgrading development. Serverless timer-based processing, software as a service, SaaS, event processing, serverless web application architecture, Azure Service Event Processing, processing of real-time stream, and serverless mobile backends will be supported by Azure Functions, in an organization. The Azure Functions service is useful to implementers in controlling tasks that respond to an event. It is more useful to the Internet of Things, so that the traditional serverless systems can easily connect to the cloud without any change in any hardware. It allows implementer increase scalability as per updated needs of organizations. Companies require to pay for only the period of functions executed. Azure Service Fabric service scales various microservices executed in the cloud environment. Microsoft uses Azure Service Fabric service for internal applications. Microsoft Azure holds second position in the cloud market share. Google Functions 24. In Google Cloud, Google Functions is equivalent of serverless execution environment. Google Cloud Functions are help in building and connecting cloud services. Google Cloud Functions are useful in building simple, single-purpose functions and are executed in complete managed environment upon occurrence of an event. Google Cloud Function has a number of services and offer various flexibility. Google Cloud Functions support polyglot programming. Google Functions can be developed using languages like JavaScript, Python 3, Go, or Java runtimes. This makes portability and local testing very easy. Cloud Functions eliminate thrust of management of servers, software configuration, updating frameworks, and operating systems patches. Google Function can scale from a few invocations per day to many millions of invocations per day. IBM Bluemix OpenWhisk 24. Serverless cloud computing platform for IBM Bluemix OpenWhisk is released in December 2016 for general use. OpenWhisk is derived from the Apache OpenWhisk open source project. In OpenWhisk documentation, microservices, web, mobile, and API backends, IoT and data processing were common use cases. Cognitive technologies like Alchemy and Watson and messaging systems like Kafka and IBM Messaging Hub OpenWhisk can also be used in conjunction with OpenWhisk. Docker container integration as a differentiating point from AWS Lambda and Google Cloud Functions emphasizes by IBM. Comparison of leading cloud providers launching serverless. 8 pros and cons of serverless technologies. Upsides. Cost-effective. Serverless computing is quite cost-effective compared to others. Lightweight mechanism of functioning. Serverless computing allows the creation and running of the app and services without the necessity to manage infrastructure. This perfect for arranging business logic. Infrastructure. Outside provider maintains infrastructure and functionality needed is provided in the form of services, and these are responsible for the processes of authentication, message transfer and so on. Fully managed service. Cloud service providers always look for a serverless computing seamlessly provide better management of server resources, by allowing developers to perform the dynamic and changing work without worrying about on which server they need to perform the task. All the resources on behalf of the developers is managed by serverless computing. Serverless computing is a completely managed service provided by the cloud service providers. Implementer need not focus on the underlying infrastructure, operating system, middleware, language runtime, and its management and dependencies. Event-driven approach. Serverless functions are invoked depending upon type of events. Function can be initiated and launched by different cloud services and existing applications that support a trigger mechanism. Infinite scalability and built-in high availability. Horizontally scales in a total automatic and elastic fashion of functions. Functions are managed by the cloud service provider depends upon the user traffic density. Less ops. For the service consumers or customers, serverless doesn't completely mean no ops. But it means less ops as operational tasks. Execution time. In a serverless technologies, clients are paid only for the period of usage and the number of functions executed. No charge is imposed if function is not executed, thus eliminating any idle time. In earlier approach, users were charged purely on an hourly basis whether they use or not, for running virtual machines. Downsides. For scaling the cloud components, serverless computing is a technological concept as per needs. Serverless platforms are even today in their earliest state. There are many serious limitations restricting applicability of serverless technologies for scaling resources of cloud according to user needs. Technology of serverless gives high flexibility to enterprises in responding to the changing needs of the application. For good performance of application, virtual servers are used rather than selecting a serverless approach. Serverless technologies is evolving technology, so debugging and monitoring serverless computing becomes quite complicated, because no usage of a single server resource. No strong service level agreements. Serverless functions yet to offer strong operational service level agreements. Many of the larger organizations though have agreements in place, but are not sufficient. Proper service level agreements are required to be in place. Latency. Serverless instantly come to an end on time to scale active instances up or down. Application implementers have limited control over this process. Continuous raised latency is achieved in case of scarcely services used. Compliance. Serverless services are non-compliant with security standards. Application providers deploy sensitive applications to the cloud, process, and transmit precise types of records. Relatively short lifespan. For serverless there is less lifespan as compared to earlier techniques. Execution environment. There is no local for running serverless services. Security concerns. In serverless approach, new level of security issues exposed, data is in transit between various functions. This will result in greater opportunities for attackers to get to system. Hence each function is handled with its own security protocols. Loss of server optimizations. 5. Client performance can be optimized by using a full backend as a service, BaaS, architecture. The backend for front-end pattern abstracts underlying aspects of system within the server, partly so that the client can perform operations quickly. In full backend as service, BaaS, architectures, all custom logic is in the client and the only backend services are vendor supplied. Both of these can be mitigated by embracing FaaS, or lightweight server-side pattern, to move certain logic to the server. No in-server state for serverless function as a service, FaaS. Function as a service, FaaS, typically has no control over when the host containers for functions start and stop. Cloud service providers always look for a serverless computing seamlessly provide better management of server resources, by allowing developers to perform the dynamic and changing work without worrying about the server task performed. Serverless computing manages all the resources on behalf of the developers. Apart from the components that are designed to store data, most of the other serverless parts are stateless. The information in stateless functions doesn't persist beyond their immediate lifespan. This leads to complexity. The interaction of these components with another is considered. Vendor lock-in. 5. Application code is made highly dependent on platform while working in a serverless environment. Architectures of serverless technology lets client applications associate directly to resources of storage and queues. Thus client code gets more tightly coupled to other platform services. Serverless features from one vendor will be different from another vendor. Operational tools, code, and design or architecture may need to be updated. Unexpected limits, cost changes, loss of functionality, forced API upgrades, will become causes for vendor lock-in. Multi-tenancy problems. 5. In multi-tenancy, numerous instances of software for contrasting tenants are executed on similar machine, and within the similar hosting application. This is plan of action to get scale benefits, robustness, and performance. An insufficient set of functions, there are no built-in substantial chains of functions. This will lead to architecture complication and infrastructure tight coupling among all the functions. This results in the same problem as monolithic architecture. 9. Need for serverless technology. 27. In deploying serverless computing, there are 4 essential points to concentrate. Support for state, U. There are some serverless platforms that are best suited for stateless workloads. For application requiring saving session state, then managing state is taken care to fullest extent in serverless technologies. Architecture, architect the application so that it can leverage the serverless architecture. In serverless technologies, it is only required to change business logic from long-running server components to functions. Cloud portability, cloud portability is considered while deciding on platform and startup latency. If the application is sensitive to startup latency, need to adopt a platform that supports warm containers to avoid this penalty. Limitations imposed by providers. One of the pitfalls of using serverless is the limits imposed by the serverless providers. Hence it is required to choose a platform that allows a high degree of flexibility from providers. 3. Conclusion and future work. Digital enterprises are very conscious about efforts, initial cost, and time. Cloud computing platforms helps them to host a project in shorter span of time, ignoring about security and maintenance cost. Both commercially and academically, enterprise serverless computing is at very early stage of conceptualization and R&D on serverless technologies. Serverless offer more reduction in cost, simplicity in use, and offer greater security. Serverless functions are adopted to run business and to get advantages of scalability, affordability, and flexibility. The code is run by using the resources required in serverless computation. In case of existing event or HTTP request, the serverless implements the task, giving appropriate information to serverless provider regarding frequency of execution of these events or functions. Amazon, Google, Microsoft, and IBM use serverless to address issues: authentication service, services of databases, storage services, notification services, and messaging services. Companies develop their own function as a service, FOSS. These services were started by Amazon Web Services and Microsoft Azure before than anybody. Mid-level companies, service-based companies may begin to use serverless technologies and serverless architectures to architect and design web app like IONS, IoT, blockchain, AI/machine learning-based applications. Serverless systems are still at R&D in the global software development. There are common standards used in serverless function like platform independence, sending of parameters of an event, CO object declaration, permission declaration, secret key management, and rest of configuration declaration. Future standardization around this need is to be addressed. At present there is a great demand for technologies like serverless and global adoption computing using serverless technologies in the software market. Among the organization's innovation and aspiration will lead to closely conduct in the area of serverless technologies. This in turn, lead to fast adoption of serverless functions wherever possible. By adopting the serverless technologies, applications achieve advanced scalability, flexibility, and affordability.